Hello, everybody, and welcome to Data Engineering Stuff. Today, we're going to talk about how to choose the right technology for your data platform. So, how do we choose the best technology for our data platform? Of course, there are multiple parameters to consider, but basically there are two parameters that I think are a bit outstanding and should be taken into account all the time. And perhaps, this simplification makes life easier, and you can simply get rid of options by using this diagram. Perhaps as a side note, if someone tells you that he can solve your problem with a two-dimensional, two-axis graphic, it will not be the full truth, and the same is here the case. But it simplifies stuff, and it eliminates options, which also helps in the process of deciding for the right technology. So what do we got here? We have the convenience of a possible technology for a data platform. So this is about how easy is it to do stuff. Is it all out of the box and I have a graphical user interface and can just do some clicks and it works? Or is it like I have to read, 100 pages of documentation and have to do upstream bug fixing to get things running because I'm using the alpha version of some strange open source project? And this is the convenience, and this is one important parameter to choose your technology. The other side is the direct cost associated with the technology you want to use. I'm not talking about operational costs or stuff like that. I talk about direct costs. So what does it cost to own this solution every month in case of license, in case of infrastructure? Only these kind of costs we want to consider here, because some of the indirect costs are part of the convenience. Because if you have to set up a complicated open source stack, perhaps the convenience is not as high, as I will show in a minute. So this is the cost efficiency. It's our second axis. And the idea is the following. If we would have a solution here, this would be the perfect solution. And we would, in many cases, go for that, because it would mean we have the lowest cost, so the highest cost efficiency, and we have the highest convenience. So if you see something like that in the wild, please tell me. But I think it doesn't exist at the moment. So there is no solution that is nearly for free and with a high convenience. It simply doesn't exist. On the other hand, this would be a solution that is, perhaps some old proprietary stuff that is really costly. It's hard to maintain. I would say mainframes and stuff like that fall into that category, but that's not so relevant for data platforms. So now you see I have four clusters, I would call it, for technologies you could go for. We start in the down right corner, and there we have the open source stacks. So what's the problem with open source stacks? First of all, they don't cost you anything if you don't buy some support with them. So if you go for something like Spark, DuckDB, Postgres, some HBase, Cassandra, whatever, Airflow. So if you build all your data platform from this, you won't have that many direct costs. Okay, the infrastructure will cost you something. It needs to run somewhere, of course, but it's reasonable low compared to other services, as the level of the service or the value you get is comparably low. Why is that the case? Because you have to know exactly what you're doing to get the open source puzzle done right. So you have to know all the exact interfaces and how everything belongs to each other. You don't get some convenient graphical user interface. You don't get an all-in all-in-one solution. So you have to put all the things together. You have to write Glue code there, Glue code here, and there's nothing ready to go. Perhaps this could be a good solution for companies that have a high tech skills and many people available, and they know some of the open source stuff already. Then this could be the way to go. But most companies try to avoid having like 10 data engineers that are really well educated in all the open source stuff. Perhaps it's not always the best way. Of course, I know there are other levels of open source stacks regarding not doing everything in open source, but perhaps use some cloud native stuff and build some open source tools on top of it, or use open source tools on top of it. Would be also a possibility. But yes, we want to simplify the world here. So we do one cluster, and this is in the downright. So the next more convenient level is the cloud native stacks. So what do I mean with that? I'm talking about the AWS Glue, the data factories, the Azure Fabric, Google's BigQuery, stuff like that. So that are services that are tightly coupled into the ecosystem of one hyperscaler, and they are tightly integrated in each other within each hyperscaler. So for example, with AWS Glue, you get the metadata catalog. It's integrated with S3, integrated with Athena, integrated with Redshift. You can do the serverless Spark jobs using Glue. So many things work well together here. Besides the integration, they are still quite complicated to use, because as they abstract many things away from you, for example, many of the things are serverless, which reduces the burden of managing the whole infrastructure, and could be cheaper if you do it right. The base cost of these services is much higher. So if you know what you're doing, you could be cheaper if you go with open source stacks. If you're doing something wrong with cloud native, could be really, really expensive. You can get a really huge bill using AWS Glue if you do it in the wrong way. So I would say they are a bit more convenient because of this integration stuff, and you get this infrastructure as code stuff there. You can deploy everything in one cloud development kit or a biceps script, which is much more easy to do than with open source. But on the other hand, it could be more expensive, and you still need a lot of know-how. So we get to the next point. This is the cloud data warehouses. I split them out from the cloud native stacks. Of course, you would say they are cloud native. I also mentioned Redshift 1 minute ago, but they are a bit special because it's still a data warehouse. It's tightly integrated with all the cloud native stuff, but they are quite expensive. I think it's the most expensive solution you could go for. It depends on your setup, but as the storage and the compute are tightly coupled together, and they are most of the time running 100% of the time. So what I want to say is there are serverless cloud data warehouses, but I don't know how often you see them in production. But basically, cloud data warehouses are quite expensive. They are huge machines sitting next to each other, talking to each other, replicating stuff and so on. And yeah, they are quite expensive, but also they offer a bit of convenience because they're well integrated. They also feature job orchestration and stuff like that. They're integrated with your IAM policies and so on. So they're quite easy to use, I would say, in contrast to cloud native stacks where you have to stick together all the different puzzle parts. And then the last part are the full service solutions. These are the solutions that, in my opinion, have the highest convenience, but they are also quite expensive. I think most of the time they are not as expensive as the cloud data warehouse because they are more intelligent regarding resource usage, and they are typically based on a data lakehouse architecture, which is a bit cheaper in regards to storing the data. What are full service solutions? These are the Databricks and Snowflakes that are out there. These are really solutions that do everything for you. So you don't have to you never have to look at something around them. You just have to work in their ecosystem, in their UI, and you get everything there. There are metadata catalogs, there are data quality, there are job orchestration, there's streaming. There's everything you need to build a data platform in there. So when do I use them? I think they are the most useful when you want to have not that many people working as a data engineer. So you want to be efficient regarding people management and stuff like that. So you want to have a solution that is quite fast up and running. And perhaps you don't have the capacity to organize or to manage an open source or cloud native stack. So then you would go for them. Keep in mind that if you are doing stuff wrong there, they could be quite expensive. So for example, Databricks configured in a wrong way can be really, really expensive. And then it could be even expensive, more expensive than a cloud data warehouse. But that are basically the two parameters, convenience and cost efficiency, and how these clusters of technologies work in there. At the end, as I said, we only had two parameters taken into account, but there are many more. You have to think about what is your team able to deliver in regards to the people working there, simply the count of people, their ability, also their mindset. Do they want to use like the fancy open source technical stuff, or are they happy to fulfill business needs and are happy if that works very well? Then you have to think about budget. Sometimes the employee budget stuff is not the same bucket as the infrastructure part. So some cases could be better to invest in one of them a bit more. It depends on your use case. Some technologies are not well designed for specific things, so you just have to think if you need streaming data, batch data, structured data, unstructured data, and so on. You have to think about interoperability with, for example, existing stacks. So, for example, if you have a Postgres in production, could make sense to use Kafka because you can easily get a CDC in place. And yes, at the end, there's security and maintainability and stuff like that you have to take into account. So hopefully that helps. Think always about what is the convenience, what is the direct cost associated, and take that perhaps as a first starting point to go into the right direction. Don't take this as the full truth. You have to take into account everything else that is relevant, but it could be a first measure, and perhaps a first idea if you have, for example, to look for data warehouses, if you have to look for open source stacks, or you go for the full service solutions. So hopefully that helped. And yeah, thank you and goodbye.